All right, let's get started. So as you're well aware, we had the deadline. Anybody have homework 2 questions before we get into WebRTC? Any post-mortem you want to talk about? Yeah.
If the image upload works like 90% of the time, is that going to be an issue?
Maybe. Maybe.
You're going to grade it like a couple times, right? Like try to upload a few.
It depends what's causing that 10%. So the question is, if the image upload works 90% of the time, is that a problem? It really depends on what the issue is and what's causing it that 10% of the time. Not uncommon case, I'm not saying this is what applies to you, but to make it more general, a not too uncommon case is students hard coding the code to work on their machine with their browser. Especially, hopefully none of you are still doing this, but there might be 1 or 2. But hard coding the indices for the headers. Like you get the headers, you split on /r/n, and then say the header at index 12 is going to be is going to contain my boundary. Some students do that, and then it won't work at all when the TA grades it because their browser is going to send the headers in a different order with different number of headers and everything. So when that's the case, that's just broken, and that's horrible code, and you should feel bad about typing it. But that might sound cruel, but at a 300 level CSE class, yeah, you should. I'm sorry, but so if that's the case, then that's one thing. If it's some strange error, it might be completely innocent and might be fine. But it all depends on what is causing the inconsistency. Because it might be something that's perfectly innocent and fine. It might be something that's just completely disregards the protocols and what you're supposed to do. So it all depends. It's a lot of different situations. Yeah. Yeah, the XSRF, cross-site request forgery. Mm-hmm. Yeah, that's fine. You have a predetermined list. Oh, you mean you're not randomly generating them? Oh, that might not be. That might be a judgment call. I might have to confer with the TAs and let them make a decision. How long is the list? So you have 10 predetermined tokens that you're recycling? That'll be a specific question we'll have to talk about on the grading side. We can talk about it. But if you have 10, I don't know if I'm fully understanding it, and it's not going to apply to everybody, so we'll talk later. But if in the case, I think I misheard him, I don't think this is the situation, but if you had 10 pre-generated tokens that you cycled through, that would not be okay. Because an attacker just grabs one of those and then keeps reusing it. Your server's not going to be able to tell that it's being reused. I guess it'd be okay if you... we'll have to think about that one on the grading side. Yeah.
I have a question. When you did the XSRF token, or XRF,
Yeah.
it said that we should allow previously made tokens to be used. I don't really get that, because what if you just, I don't know, say you only have a million combinations, what if you refresh them a million times or something?
As long as you're randomly generating them, I'll be okay with it. Right. So there will always be a finite number of tokens that can be used, but as long as you're randomly generating them, I'll generally be okay with that. But if you have fixed it to what I was just saying, won't really apply to anyone, I hope. But if you have like a list of 10 tokens and say these are my tokens and that's it, that'd be the same as like randomly generating a token that's just one letter that's either A through J. Like, that wouldn't be okay either. There's just not enough entropy there. Yeah? This question came up. So the question is, do we have to write our own HTML escape function? This question came up, and I'm trying to remember what answer I gave last time. Does anybody remember what I said? I think this did come up in lecture. And nobody remembers. Yes. Do you have to write your own HTML escape method? Yeah, but if somebody already submitted without doing that, not knowing if they had to or not, it's one where I wouldn't really want to penalize somebody because, like, that's such a small part of this homework. I'm going to say no, you didn't have to write your own. So if you imported HTML and did HTML.escape, I'm assuming? I'm going to be okay with that. TAs, make note of it. Jesse said that, it's okay. Because I honestly don't remember what I think we had that discussion, or maybe I just dreamed it, because nobody else seems to remember. Yeah.
For all that testing, is it possible for the cloud container to run on live servers? Just so we can test the secret code running over the container as a Docker live container. So we can have secret configuration as a student. And that's easier for testing. If you download the code like a
I can hear like half your words. So running Docker in Autolab to do automated testing, is that your question? Yeah, we can talk about that later. So one issue with running them in Autolab, if that's what you're talking about, is we don't have access to Docker Compose inside the container that's running inside Autolab. Because we need extra permissions that we're not going to give those containers because that would be a security leak, a security vulnerability. So auto-grading these is problematic. I'm also happy with that. Like, I don't think 312 should be auto-graded. I'm of the opinion that any 300 and 400 level CSE classes should not be auto-graded. So I'm okay with that. I'm not like fighting to try to find a way to make that happen because I could make it happen. I would host my server somewhere, have the Autolab container, zap your files over I'd have a web API attached to it, zap the files over, say grade this, basically build my own Autolab backend. Like I can do that, but I don't see a need to get really complicated to build a feature that I don't even want. Have you ran into an issue with this? Have you ran into an issue with this? As far as I know, this isn't really a wide issue. When we have problems in grading, it's almost always the student had something configured awkwardly. I see what you're saying. Yeah, yeah, that's something we'll think about. But Docker is the answer to that, is my issue. The Docker and the testing procedure should do exactly that. It's not 100%, but usually when it's not 100%, it's the student not reading. Usually it's like the wrong port or the wrong Docker configuration or something silly. Yeah.
The issue with having the slashes in the name of the file is the point where that becomes an issue only when you're opening a file with the open method?
No, I mean you have to open the file somehow.
Right,
but however you're opening the file, yeah.
Like when you're opening the file, that's the point where the attack is, right? Where you can't
Yes. So yes. So the question is about slashes in file paths. Yeah, the attack happens when you're opening that file. So at the point where you're opening the file, that's where you need to disregard slashes. I have a demo for that. I never ended up showing. I guess it's kind of too late now. It's not super relevant. But I have a demo where I can access the server code by putting a slash in there. Yeah. What? Ask a homework 3? Can you ask a homework 3? You can ask any question you want.
So if you had a payload length of like 126 to 127, the payload data is the next frame of that, because it's obviously not going to fit on the first frame, that have a fin bit and an opcode at the start of it?
126. It depends on your browser. So the question is, if you have a WebSocket frame that's big, will the fin bit be 1 or 0? It depends on your browser. I can tell you Chrome, which we will test on, in any Chromium-based browser, once your web frame is more than 131,000 bytes, I don't know how they chose that number, but 131,000 bytes, it will be split into multiple frames, but under 131,000, it will be a single frame. So you can get up to that 127 in the 8-byte payload length without needing a second frame, but we will test beyond 131,000 where it will require multiple frames.
So the second frame, does that start immediately after the end of the payload data for the first frame, or does it actually have like a header, like an opcode and an output?
Oh yeah, it'll have all the headers too, but those headers will be right after the previous frame. Yeah, it'll have a fin bit of either 0 or 1, because there might be 3 frames, an opcode, the masking bit, the payload length. Like, it'll have all that stuff. Yeah.
Sorry to interrupt. Okay, when you receive bytes for element 3, like the bytes you can receive, they can contain multiple parts of frames. You don't know, like,
Yes.
they can contain the end of one frame and the beginning of another.
Yes.
It's so annoying.
It is. Yeah. So the question is, when you read from the TCP socket, say I ask for at most 2,000 bytes from the buffer, can it contain multiple frames? Yes, it can. So if you're in a buffering state and you're buffering a very large frame, and during that the client sent another frame, maybe a small frame or maybe another big one, when you read that last chunk of that large message in your buffering code, that last chunk might contain the headers of another WebSocket frame. So you have to be aware of that if you're reading more bytes than you expected based on your payload length, that those extra bytes are the start of another frame. Yeah.
So when we receive multiple chunks of data, for example, if I have a large amount of data, so the second frame, will it have the headers or will it just have the data?
It'll have the headers too. So if you have multiple frames where the fin bit is 0 for the first one, yeah, the second one will still have headers. And the payload length of the first frame won't be the entire payload length of the whole thing. It'll just be the payload length of that frame. And then you would add up the payload lengths to all the frames to get the whole payload length of the entire message that's being sent across multiple frames.
And since we're going to receive, say, 2048, so that will restrict the payload length or the frame length to 2048, or
That'll restrict the number. So when you call receive and you call 2048, that's restricting the amount of bytes that you get from the TCP socket at one time to 2048. So when somebody's sending multiple frames, and they're large frames, you might have several megabytes of data sitting there on the TCP socket just waiting to be read, sitting in a buffer, and then you're going to read them in chunks of 2048. You're going to say, give me the next 2048, give me the next 2048 of whatever's sitting there on the TCP socket.
so the frame size can receive 2048 times.
Yes. Yeah. Yeah, the frame size, we'll test with frame sizes over 131,000 to make sure that we hit that continuation frame. Yeah.
You get like Hartloff though if you have multiple frames being sent at the same time and have like bytes of data.
So there's no real such thing as sent at the same time. Let me rephrase that. The browser will enforce that it's not going to send frames at exactly the same time. So the order that we're guaranteed from TCP is that the order that things were sent are going to be the same when they're received. It's going to do the sequence number, reassembly, and all that crap. So we're going to get one message that was split up across multiple IP packets and everything resequenced. We're going to get one thing that the browser sent and then the next thing that the browser sent. So the browser is going to send one frame, then going to send another frame, and the browser won't send like some random frame in the middle of continuation frames. Right, does that make sense? Like, we won't run into that issue, is what I'm saying, because the browser's going to make sure we don't. I'm assuming Nicholas has everything covered here in chat. Also, will be the alternative slicing and getting indices of the header. I might have to read that whole conversation to understand what's going on. I'm going to assume Nicholas has chat covered, but if not, somebody let me know. All right. We don't have too many slides today, so I think we can still finish with what we just talked about. I'm glad you all had questions, actually. Let's talk about WebRTC. So, I had the homework doc open. The only reason I had the homework doc open was just a reminder that you can do everything, objectives 1 through 4 of homework 3. I assume most of you are wanting to rest after homework 2 and not think about 312 for a little bit. But when you are ready, homework 1, objectives 1 through 4 are all on the table, all ready for you to do with what was covered in lecture last week. Objective 5 is WebRTC. Like I said before, with WebRTC, objective 5, there's not a whole lot for you to code. When you finally get to this, as long as, there's a big if here, as long as your WebSocket code is solid and working well, WebRTC should be super easy. You should code it up and be like, wait, that's all he was asking me to do? That was way easy for a 312 objective. And that's like kind of by design. Parsing WebSocket frames is going to take you a while. I understand that, and I don't want to pile too much on top of that. So parsing WebSocket frames, now that you're all through homework 2, I can make this comparison. Parsing WebSocket frames and sending WebSocket frames is very much similar in terms of difficulty as parsing your multi-part form submissions. And I understand that in the homework, like it's designed that way, where the parsing the multi-part form stuff and not breaking the image, not converting the image to a string in the process, was the bulk of the difficulty for homework 2. Homework 3, same thing, parsing these WebSocket frames that you're getting is going to be the bulk of the difficulty of homework 2. Or at least that's where I expect the bulk of the difficulty. Everybody seems to run into different little issues that end up taking tons of time. Unfortunately, that is kind of part of programming. I don't know how many tasks, like programming tasks I sat down to do and I said, this should take me an hour, I'm going to knock this out, I know how I'm going to do it. And then I run into one tiny little bug which takes me 3 days to debug. It happens all the time. So you might hit one of those, but the bulk of the intended difficulty is parsing WebSocket frames. I'm sure you've all experienced that same exact thing by now in your careers. Yeah?
Should it actually be easier than parsing multi-part forms because it's all at a bit level, so you actually know exactly where everything is and you just do like ranges and stuff?
I'll say that depends on each person. It depends on each developer. It depends on what you're comfortable with. I think most of you right now are not super comfortable doing bit-level manipulation in your code. So I would expect the WebSocket frames to be more difficult. But if you happen to have done a lot of bit-level manipulation in code, specifically taking 8 bytes and combining it to one int, like that takes a little bit to figure out, or at least a couple Google searches. So that can be tricky. Where at least with the multi-part form stuff, like it was tricky to figure it out, but at least you knew like how to write the code. I don't know. They're different, I'll say. I think they're about on par with difficulty, but they're very different. So it depends on what you're comfortable with. All right. Let's talk about what WebRTC is. Is there any more questions? Any last second questions? Going on to new content. So, I forgot I put these review slides in here. So to review WebSockets, which is the bulk of what you're doing with your homework, so I'm fine reviewing this. But WebSockets, to initiate a WebSocket connection, the client is going to send you an upgrade request. It's going to be an HTTP request, just like any other HTTP request we've seen so far, except we're going to treat it much differently when we receive it. But it's going to be in the same format, headers, /r/ns, things like that, things of that nature. There are going to be 3 important headers: connection upgrade, connection with the value upgrade, upgrade with the value WebSocket, and this key WebSocket, I forget what it is, sec WebSocket key, which is going to be the important value to read from this. So more headers to read. I've said this plenty of times by now. I have to stop saying it at this point. But if you don't have your generic header parsing code by now, you've felt the pain of every time you need a new header that you have to read, you got to go in there and read it manually. Probably a pain. If you had that header parsing code from homework 1, it's been paying off for you. Same thing will be true for homework 4 when we start working with cookies. Cookies, I'm sure you're all aware of what cookies are as a user, at least to some level. What you might not be aware of right now is, well, I'm just going to tell you, cookies are handled strictly through headers. There's a header for all your cookies. We set cookies through headers. It's all headers. So more header parsing. Hopefully you have that header parsing code and you've been seeing the benefits of writing it once and using it for all the homeworks. But you're going to want to read this header, take this random key, send back a response, which is going to be the key. To the end of it, append that globally unique ID for WebSockets. Take the SHA-1 hash of that, and then take the base 64 encoding of that, and then set that as your accept header. And then send a 101 switching protocols response with these headers unchanged, the sec WebSocket accept with that value you computed from the random key, and then keep that connection open. We're going to keep that connection open to be able to receive WebSocket frames and send WebSocket frames to and from and to this user. Yeah?
How is this connection actually kept open now?
You just don't close it.
I mean, like, do you set up a loop or something?
Yeah, and I think it was Friday or Wednesday. Yeah, Friday. You could use a well true. I have a TA who does not like, oh, they're not here today, but who does not like well trues and said, you should never use a well true, but I like using well trues, mostly because I think it's funny.
Do you put that beneath the actual call to establish an action?
Yeah, when you send your response, your 101 response, the next thing you should do, well, for the homework, the next thing you should do is generate a random user ID. But then after that, you're going to enter a loop, which you intend to loop until the connection is closed. So if you don't like well true, you could do like well connection shouldn't be closed and have a Boolean flag or something like that. I think that's grosser than well true, but.
What, do you call off the request method again, or do you have to write everything inside of it? Or?
Yeah, you call receive inside of that loop.
Okay.
And what you receive, you're expecting to be WebSocket frames and not HTTP requests.
Oh, so it'll be different from all the other code, so you can safely put all your web frame code in there?
Mm-hmm.
I see.
And then once that connection's open, when we're in that loop, what we receive, just the same way that you receive HTTP requests, except the bytes that are sent over that TCP socket from that client, you're going to expect to be in this format as a WebSocket frame. So the client sent you this request, hey, let's upgrade this TCP connection from HTTP to WebSockets. Once they do that and you do the whole handshake, do that whole dance, the client should be sending these things. You would expect them to do that, so in your code you can assume that they're going to send you WebSocket frames. So on that TCP connection, you're expecting WebSocket frames at that point and not HTTP requests. Yeah.
So when you're receiving WebSocket frames, it will be in chunks. So how do you know if a whole frame is received and you need to process it now?
By reading the payload length. Right, is that your question?
Yeah. So the payload length and frame length.
The payload length is what?
And the frame length.
And the frame length?
Yeah, like.
So the payload length there is the number of bytes in the frame. So after the masking key, every byte after that is part of your payload. You want to read those bytes until you read payload length, the number of bytes. Just like when you parse the content length header, and then after that blank line, you make sure you read that many bytes. It's the same thing here. After all the headers, which the last header for frames you receive will be the masking, 4 bytes of masking key. Everything after that is your payload. So you want to read that many payload length number of bytes after that masking key. And just like with HTTP, you can assume, which is a very safe assumption with the WebSockets, you can assume that in the first read from the TCP socket that you get all the headers. So you're going to read once, you'll get at least all the way through the masking key, so you can parse that payload length right away and get that information. I guess there would be a situation where that's not true, where if the end, where you're getting multiple frames in one read, and you happen to only get like 1 byte. That could happen. If that's your bug, I'm giving you credit. Like that would be a really obscure, very unlikely to hit bug. Yeah.
So it starts with the client sending a GET request, it sets the headers, server responds with a normal response, and then there's just communication with WebSockets?
Yeah.
Or the client communicates with the server using WebSockets, server responds with responses?
You respond with WebSocket frames. Everything over that TCP connection from then on, after the handshake, is only WebSocket frames in either direction. So when you're responding to the client, you're responding with a WebSocket frame in this format, in this exact format. You're no longer communicating HTTP over that TCP connection. If the client needs to talk to you with HTTP, maybe they need to request an image or something, they're creating a new TCP connection. So one client can have as many TCP connections with you as they want. They're just going to open up a new TCP connection on another port, on a different port. Yeah.
You read the frame and you get like the whole data payload, and then you start reading the next frame, and that next frame doesn't like fit with the whole red key. How do you know that you're on the next frame? You're on a new frame.
Because you read more, but you received more bytes than the payload length. So if my payload length is 5, and after reading the mask, I read 10 bytes, I know I got 5 bytes of the next message. The numbers will, of course, be bigger, but.
Wait, so then if you have 2 frames that payload data is continued on the second frame, does that payload data's length represent payload data for that second frame?
Are you talking when the fin bit is 0?
No, I'm talking about the payload length for the extended.
With a fin bit of 1, you read the payload length, you read that much payload, and if you have more bytes, if you're like, I was expecting 1,000 bytes and I got 1,100, I got 1,100 bytes. You got 100 bytes of the next payload. And the first few bytes of that will be the headers, the payload length, etc. Is that your question? I feel like I might have missed your question. Okay. Yeah, we can talk after lecture, and we can get there. Payload length can be 7 bits, 16 bits, or 64 bits. We have masking bytes, 4 bytes of masking. The payload is masked with that masking key, those 4 bytes. And you're not masking anything that you send back to your clients. You don't mask anything. Yeah.
Will you still need to set the masking key in your response?
No. You set the masking bit to 0, which is the indication that there is no masking key, that those 4 bits just aren't there. So right after your payload length bytes would go directly into your payload. No masking byte, no masking key bytes in the frames that you send.
And can we assume that a request will always have a masking bit byte?
Yeah, I got to correct your vocab a little bit. They're not requests. So WebSockets isn't a request response protocol. Actually, I think I messed that up too. I said responses. But yeah, when the client is sending you a message, a frame, a WebSocket frame, it will always have a masking key and a mask bit of 1. Every browser is going to do that because it's designed to bust caches. So every browser has that implemented. If you run into a situation where you get a frame that's not masked, I'm not going to hold that against you. Okay. What is WebRTC? Run my server. Listening on 8001. I'm going to refresh. So what we want for WebRTC is a peer-to-peer, oh, that's weird. I'm going to get the projector in there too, is a peer-to-peer video connection. Oh, don't crash on me. Here we go. So I'm going to start my video on each of these. And I'm going to click this Start Video Chat button. And it's a little awkward because it's the same camera for each of these. And I forgot to mute, but luckily I'm not getting any crazy stuff. So it's the same camera, but this is a peer-to-peer connection. I have 2 TCP connections with the server, which are severing those connections and creating a UDP connection with each other. And if you watch close, there is a little delay. One of these is being sent across a network. It's all internal to my laptop, so it's almost no delay. But this is what we want to build, a way to have peer-to-peer video chat in our apps. So that's our goal. Let me get my face off here. For homework 3, yes. Objective 5 is to build that. I give you the front-end code, and objective 5 is to build that, peer-to-peer video chat. That's what we want. Oh, my brain. There we go. So a live streaming peer-to-peer connection. That's what WebRTC gives us. That's what we're after. So we have real-time communication with a server. So there's a big difference here. We have real-time communication with a server through WebSockets. Actually, a few big differences. Through WebSockets. We can communicate. It's bidirectional communication by using the TCP socket connection and communicating both ways with WebSockets. I would say that's live. I guess I would only consider that to be live, not streaming and not peer-to-peer, though a lot of these terms are overused and overloaded to mean so many different things right now. But I'll explain what I mean by that. So that's what we want to build, is this video chat app. And it does have audio on there. Luckily, oh, good, the program audio was muted right here. That's what saved me. There'll be all kinds of distortion because it's on the same device, and it's just a big feedback loop. So usually like squeals, and luckily this was muted. This came out in 2018. I shouldn't say it came out in 2018. This came out a while ago. It was in development, but it was finally had a stable release in 2018 where the spec came out and it said, this is WebRTC, this is how you implement it. The RFC came out, was finalized. 2018 was when this started. So this is fairly new technology. I mean, not super new, but 4 years. New enough that you might see some strange oddities in certain browsers. The major browsers have this pretty well figured out. I mean, most browsers are just using Chromium. Chromium has this figured out, how to implement WebRTC. But if you use like a lesser known browser, you might not see the features working completely because it is, it's pretty new. And any user with an out-of-date browser, for example, somebody who hasn't updated their browser since 2018, yes, they are out there. If browsers don't auto-update, some people just don't. Even with auto-update, I sometimes don't, as we found out in that other lecture, that I never restart my browser or my laptop, so auto-update never gets a chance. But 4-year-old browsers won't have this implemented. So just keep that in mind if you're going to use this out there, that you are alienating some users. So just something to keep in mind, not something I want to dwell on too much. And a lot of the logic here, and the reason why Objective 5 there isn't too much code to write, is because most of it's in your browser. The browser does almost everything for you. You have to interact with that code a bit, but since this isn't a front-end course, I give you the front-end JavaScript to be able to interact with that. So server-side, there's just not much to write. There's not much to do. It's mostly front-end. It's mostly something that we can do for fun for this course. So WebRTC is a live streaming peer-to-peer connection. I want to piece apart this sentence and talk about what each piece means. So peer-to-peer. This is a peer-to-peer protocol, strictly a peer-to-peer protocol. If, I should have done that as part of my demo. But your server is involved. Obviously, there's something to write on your server, but your server is involved to facilitate a connection between two clients. Two clients are going to communicate directly using this protocol. Your server's purpose is to facilitate that connection. The one client is going to talk to you and say, hey, I'd like to start a peer-to-peer connection with this other client. And then you're going to pass a few messages back and forth. And then after that, they're just talking to each other. Peer-to-peer, it is serverless. What I wish I showed in my demo, I'll show it on Friday, is once the connection is established and we have that video feed going between two clients, I can shut down my server and that connection persists. It's a true peer-to-peer connection. It is serverless. There's no server involved after the initial configuration, or after the initial negotiation, the initial handshake, if you will, to be able to set up the connection. So if you're concerned with privacy, of course, reminder, your ISP can still see your data and stuff like that. But if you're concerned with the servers seeing your stuff, this is a nice protocol to be able to get direct connections, direct video chat between two peers. It is live streaming. So this is actually streaming data. When we're, I want my next slide actually. So we're live streaming. We want fast communications. Apps like video chat, like Zoom or the day Skype, anything where you're live communicating with someone, or just voice chat even, we actually need some live streaming features, functionality to this. Unfortunately, TCP doesn't do that. TCP is meant for reliability. Whenever I talk about TCP, I'm like reliability and sequence numbers and reassembling, all that stuff. Never when I'm talking about TCP do I say, man, it's fast, because it's not. Just to establish a connection, we got a three-way handshake. I guess that only would have to happen once in this case. And then to send information, if we have a dropped packet, if I'm sending some information, I have a dropped packet, there's a resend request, there's a wait. We have to wait for the resend to come in before reassembling any of that data and sending data to the user. This can all introduce lag, and if you're video chatting with somebody, you don't want that kind of lag. What we want is all the packets to just be sent, and if we drop a packet, we drop a packet, and that's it. That's what we want. So we're going to get live streaming with that functionality. Yeah.
Like going back to week one networking, the packets are sent over the internet just straight to the IP address of the second guy?
Yeah. Yeah, with not being sent to the server. Because like with WebSockets or with just about anything else, you send information to the server and the server sends information to the other person. Here we're sending to the other person directly. And this usually isn't the case. Usually we use TCP for what we call streaming. Streaming is an overloaded term right now. So if you're watching YouTube Live or Twitch, anything with live streaming, what we call streaming, it's not streamed in the way that I'm talking about here. That's actually using TCP and other protocols because you can afford a few seconds of delay and it's not a big deal. If you're 2 seconds behind on a stream, who cares? Like, it doesn't matter. If you're 2 seconds behind on a video call, that matters. If you have a Zoom call with a 2-second delay, that's a big problem. So WebRTC actually uses a different protocol called UDP. This is instead of TCP. It's at the same layer. So this uses UDP, which is similar to what WebSockets do for TCP. UDP does for IP and basically just says, let's just use IP. And it's a very minimal protocol that just says, let's use IP and just send the packets. If they get there, they get there. If they don't, they don't. Just like IP without any protocol on top of it would do. You just send the packets and hope they get there, and if they don't, they don't. Yeah.
Like a lost or dropped packet look like on a live stream?
It just cuts out for a second. So if you drop a packet, you see a still image for like a brief moment, and then it picks up again. You think there was a little lag or whatever. That's all it looks like. On Zoom, when somebody freezes for a brief moment, drop packets, and who cares? Probably their internet just couldn't keep up for a moment, whatever happened. You just drop a few packets and it's fine. Because you don't want old packets. When you're video chatting, you don't want your app to say, oh, by the way, here's some packets I got that were sent a few seconds ago. Want to go back and see what that person uttered at that moment? Like, no, I don't care. Let's just move on. Let's move forward. So there's different servers involved with WebRTC. Where's my... Okay. With WebRTC, I'll talk about them briefly here. I just want to introduce them. And then on Wednesday, I'll go into depth on each one of these servers and what they are. One is the signaling server. This is the one you'll actually implement. This is the only one you'll code in your server. This is the server that's facilitating the initial communication. A client, two clients are like, hey, we want to connect with a WebRTC connection. You go through the signaling server, and the signaling server forwards, really doesn't do anything. There's no processing that you'll have to code, but it's going to forward the messages. We got two clients that want to connect. One client says, I want to connect. The signaling server says, hey, you got an I want to connect message. And then there's several other message types that go back and forth to be able to establish that connection. There's a stun server. I guess I'll do this. I'm like, I should just save all this for Wednesday. But a stun server, we have a problem in a lot of cases where your device doesn't know its own IP address. It's very common. If you ask your device for its IP address right now, if you go into the console and say, what's my IP address? It'll say some local IP address. It'll ping the access point and say, what's my IP address? You'll get your local IP address, but you won't get your public IP address because you're usually behind a NAT. So you're going to have one, that's a misnomer, but your local IP address to your router is going to be different in most cases to your public IP address. So what we have are stun servers, which are servers that just say, this is your IP address. So you send a message to a stun server. The stun server says, I got your message. It came from this IP and port. And that'll give you your public IP and port. And then you can use that during that negotiation with a client to say, hey, here's how you can connect to me. Because if you give them 192.168.00 or 01, that's not going to be helpful because that's going to be your local IP address. And finally, turn servers, which usually aren't required. These are usually optional, and I think they're can't think of a good word. I'll just say what I have on my slides. I think they defeat the point of WebRTC. But what turn servers do is route all of the information for you. So instead of having a peer-to-peer connection, if you're behind some firewall that's not going to allow a peer-to-peer connection, what you can do is go through a turn server, and that turn server is going to route all the traffic for you of your entire connection, of all of your video chat and our purposes. You can send that any information you want. I'll use it for video chat. But for my money, what's the point of WebRTC of creating a peer-to-peer connection if you're going to involve a turn server? You have to be in a position where you trust the turn server more than whatever other server you would trust that you're trying to avoid by having a peer-to-peer connection. You're just transferring the problem to another server. So unless you set up your own turn server, which would be a possibility, if you set up your own turn server, that's fine. But to me, it really defeats the purpose of WebRTC if you're using a turn server. We won't use turn servers in this class, in the homework. You do use a stun server. It's hard-coded in the front-end JavaScript that I gave you. You only have to ping that once to establish the connection. Turn servers we're not going to use because it defeats the purpose. It's silly. And you only implement signaling server. Details in the next lecture. All right. Oh. What's the actual time? I can never know the actual time in this. 47. Anybody have quick questions? Yes?
Yeah, not anything with regard to WebRTC, but something with regard to homework 3 objective point.
Mm-hmm.
Okay, so in the JavaScript code you gave us, when it does the Windows host, Windows local host, when it creates the socket, right?
Yeah.
And then you just add the /WebSocket, that automatically sends a GET request to /WebSocket that you load up the page?
Yep.
Okay.
Yeah, and I shouldn't start a demo this late. in lecture. But it's window.host. There's something else in the middle there. Does anybody know off the top of their heads? Location. Ugh, I don't want that. So this will give me the host. It'll just give me, in this case, localhost 8001. So if you just read that as localhost 8001, creating the WebSocket connection will send a request to that host port path combination. Yeah, no problem. Have a great day. I'll see everyone Wednesday, where I'll go over the details of WebRTC.